All right, we're starting chapter 12, which is on chi-square tests. So let's recall in the last chapter, we extended the idea for testing for difference in means. So recall we did a test for difference in means from two groups to three or more groups. So in chapter 10, we looked at comparing differences in means between two groups. And then in the last chapter, chapter 11, we extended that idea to comparing means between three or more groups. And we did this using what we called the ANOVA procedure, the analysis of variance procedure. So we're kind of doing something similar in this chapter. It's just instead of working with means, we're going to be working with proportions. So now we're looking to test for a difference in proportions. We're going to extend this from two groups to two or more groups. And we will do this using what we call the chi-square test. So if you remember back in chapter 10, we compared proportions using the z-test. So we did the z-test for differences in proportions. So our null hypothesis was that pi 1 was equal to pi 2. The alternative was that they were different from one another. So here, we're just kind of doing the same thing we did last chapter. It's just now we want to extend it past two groups. We might want to compare proportions between many groups. So we're going to do this with the chi-square test, just how in last chapter we compared multiple means with the ANOVA procedure. So our hypotheses, so this probably shouldn't be much of a surprise, is that we're just setting all of our proportions equal to one another. So pi 1 is equal to pi 2 is equal to all the way up to pi c. So we're still saying c is the number of groups we have. So maybe I should say c is number of groups. And that number is going to be at least 2, maybe bigger. It could be 3, 4, 5. It could be anything. And then the alternative is just that that's false. At least one is not equal to the rest. Of course, it doesn't mean they're all different. It just means at least one or multiple. We don't know which. So our research question essentially is just, do proportions differ across these different groups? So recall that a proportion is just the number of successes out of the number of observations. So we've defined this. This goes all the way back to like chapters 3 and 4. It's just x over n, x being the number of successes, n being the number of observations. Our proportion is just the percent of successes out of all of our observations. So when we're doing a chi-square analysis, what we're going to be doing, we're going to be comparing observed counts. So we're going to compare observed counts, and we're going to call that FO, for F is frequency, O is for observed. We're going to compare that against expected counts. And we're going to call that FE. So F for frequency, E for expected. So in other words, F naught, or our observed frequency, is our actual data, or the observed counts. Or maybe I should say observed frequency. And FE is the expected count, or the expected frequency, FE, and it's just going to be defined as the row total times the column total, so that's a times multiplication, divided by the overall total in the data set. So we're just going to have our contingency table of observed or actual data values, and then we're going to create an expected table, and then we're going to take the difference between those, and that's going to define how our chi-square test statistic. Okay, so let's look at an example. So this is from our textbook. So we run some resort, and we have a collection of 5 upscale hotels on 2 tropical islands. Guests who are satisfied with the quality of service during their stay are more likely to return on a future vacation and to recommend the hotel to friends and relatives. We've defined the business objective as improving the percentage of guests, so the percentage of guests who choose to return to the hotels later. To assess the quality of services being provided by your hotels, your staff encourages guests to complete a satisfaction survey when they check out or via email after they check out. Okay, well, the book says 5 hotels, but then they only give us 3. So, okay, let's ignore the number 5. So we have what are observed frequencies or our actual data from the survey. Okay, so this is literally the data we collected from our customers. All the customers who went to these hotels, they took the satisfaction survey. This is how they responded. So this is what we're calling our actual data or the observed data or the observed frequencies. It's the real data. Okay, so we can see, would you choose this hotel again? Well, you can either say yes or no. And then we'll sum that up with a total column. And then there are 3 hotels. There's Golden Palm, Palm Royale, Palm Princess, and then we'll sum over the total. And in total, we have 700 customers who responded. So what we want to do is calculate our expected frequencies from each of these groups. So let's recall, so calculate expected frequencies, which we're going to call FE, and it is equal to our row total times our column total divided by our overall total. So we need to do this for each of our 6 outcomes. So Golden Palm, yes. Palm Royale, yes. Palm Princess, yes. Golden Palm, no. Palm Royale, no. Palm Princess, no. Okay, so let's do that. So let's start with our expected number for Golden Palm who would return to this hotel again. So let me say yes, Golden Palm. Okay, so this is equal to the row total times the column total. So maybe I should use different colors. So the row total, total for Golden Palm and yes is going to be 513. And then the column total would be the column total for Golden Palm. And then our overall total is going to be the 700. So let's do this. Golden Palm. So expected numbers, row total. So row total is 513, right? 513 times column total, 216, right? Column total divided by 700, our overall total. Okay, so now let's just do this for the others. So let's do yes, Palm Royale. Okay, so row total is the same. So here we're now moving over to Palm Royale. So row total is still 513. So 513. Our overall total is never going to change. This is still going to be 700. But now we have a new column total, so 232. So let's go 232. And I forgot to calculate this first one. So if we calculate this first one, I get 158.3 and 170.02 for Palm Royale. Okay, now let's move on to Palm Princess. So our column total will be 252. So we're looking at Palm Princess. So we're doing yes, Palm Princess. So row total is unchanged. It's 513. So 513 times our new column total of 252 in green. And our overall total is always going to be 700. And I get 184.68. Okay, so we've taken care of our yes row. Now we need to take care of our no row. So now let's say no golden palm. So now our row totals are going to be here and here. And now we are looking at golden palm no, and therefore our column total is 216 again. So this will now be 187 times 216 divided by 700. And that is 57.7. Now we want to do no Palm Royale. So we want Palm Royale. Palm Royale, no. So we still have 187 for our row times 232. I'm getting a little carried away here with my colors. 232 divided by 700 is equal to 61.98. And then finally, no Palm Princess. Row total is unchanged. It's 187 times, so we have 252 for Palm Princess. So it's now 187 times 252 all over 700. And I get 67.32. Okay, so we just calculated our expected values for this whole table. So I actually have it right here. We have our expected frequencies. So let me move this up. So let's just take a look. So yes, Golden Palm, we had 158.3, 158.3. Yes, Palm Royale, 170, 170. Yes, Palm Princess, 184, 184. If you sum those up, you still get 513, 513. Now let's look at our no. We have 57 for no Golden Palm. We have 61.98 for no Palm Royale and 67 for Palm Princess. There we go. If you add all of this up, you get 187. And same if you add up this way, you would get 216, 232, 252, and 700, which are all the same here. All of our total numbers are exactly the same. It's only the middle of the table, which I have highlighted down here, are the expected values.